Hello everyone, this is Wei, and today we're going to talk about OpenLive3D, and to be more specific, we're going to talk about how you could slightly adjust the settings for your personal use, right? Uh, Before we talk about adjusting settings, these settings have been tuned for quite a while, so the default setting should work most of the time. However, we know that every human being is different and quite a lot, so there are a lot of settings that we can still further adjust for every individual, of course. So today we're going to look at that. Before we're diving into these settings, uh, I adjust the setting a bit, right? So when I check all these setting name in the previous version, I found that for smoothness, we're having like blur, smooth, stabilize. For threshold, we have offset, close, open, limit. For magnification, we have ratio, scale, strength. Frequency is just frequency, right? So these names are not generalized or normalized, right? So we have all different kinds of name that while sometimes they might not uh, be the same. So I slightly adjust the OpenLive3D setting name a bit so that at least there is some cohesion, right? So for smoothness, it will always call smooth. For threshold, if it is talking about the lower bound, it will be offset, right? Only when the value exceeds a certain value will something start to take effect. And for the upper bound, it will be limit, right? You might ask why we're not just using lower bound and upper bound. It is because like we have limited space in the name, so we choose a shorter tractor. And for magnification, we always use ratio, so it's consistent, and frequency is just frequency, right? So let's start to look at our OpenLive3D, right? So this is the OpenLive3D. We can click on the logo and let's slightly adjust the background a bit so we don't need to constantly look at this green background. It's easier for our eyes. Right. So in the setting, there are general, smooth, body, mouse, browse, eye, general, eye, right, left, hand, position, and UI. There are quite a lot of settings to tune. Right, so let's start with general. Right, so in general, there is a save setting. If you turn this on, it will save the model that you're using and also other settings that you are using. That is to say, if you want to reset all the settings, just remove this save setting and then close the program, open it again, everything will be set to default, right? So this save setting is basically a way for you to remove everything that you have set, right? So this is also, you can also trick this like a way to set to default, right, if you want. For camera flipping, it's quite obvious. Toggle camera on or off, it basically means that if we want to close the camera recording or not, right? So if you click it, things will stop, right? Language settings, quite obvious. So brief frequencies, right? So this is the settings that we can change. Currently, this is 0.3. What does it mean? It means that it takes it means that it takes 3.3 seconds, 3.33 seconds for our model to move in one up and down cycle, right? So if I'm not moving, you'll see that my model is still moving up and down a little bit, right? So the frequency is controlled by this brief frequency. And the magnitude is controlled by this brief ratio, right? So ratio is basically how, what's the magnitude that you will move your model up and down, right? So if we change this value to larger, you'll see that our model is definitely moving up and down quite a bit. So let's change it back to 1. Okay, so this mood auto ratio is a way that we're currently using the edge of your mouth to detect whether you're happy or not, right? So if the edge of your mouth is above the center of your mouth, it means that you're probably happy. If it is lower than the center of your mouth, you're probably like sad. And there is a ratio that we're tuning to affect the mood auto detection. Uh, so the mood auto detection is always not so vibrant or violent or aggressive, right? So because I found that it would be quite strange if we keep changing our mood, like in 1 second it's happy and in the next second it becomes angry. So it's quite strange. So the ratio is not set to very high, and there is an offset, right? So if the edge of your mouth is not compared to the center of your mouth is not exceeding 0.04, then the motion will be normal. Basically, this is what offset means, right? So only when the value exceed a certain amount will something start to take effect. For for mood auto, it basically means that only when the edge of your mouth compared to the center of your mouth exceeding 0.04 will we start to consider that you are happy or sad. Okay. And here is a 3D FPS limit. It basically means the upper bound, right? So these are the limit that I set. 40 means that the highest FPS that we can go is 40. You can also check these parameters in the general. There is a FPS settings. Sometimes it will slightly exceeded it a bit, but it should work. Like should try to limit the value like below 40 most of the time. Sometimes it will exceed it a bit, but it should be fine. Right, for ML FPS and 3D FPS, these two are slightly different, right? So for 3D FPS, we're trying to render the 3D model, the model that you're currently seeing. For ML FPS, it basically means that how many frames we're going to run our machine learning model, right? So limit means the upper limit. It depends on your hardware spec. Sometimes your computer is just not beefy enough to run through this value. For example, in my computer, it's actually not very good, I would say. I can only reach around like 30, 40, something like that. So it depends on your computer quite a lot. If you see that your FPS is not that good, if you think your model is like stuck a bit sometimes, not so smooth, maybe like lower these two value to like 30, and you will be a lot smoother, right? So let's talk about smooth. The next one is smooth. Like we have a lot of different smooth settings everywhere, right? So many places we are adding smooth settings. The reason is because the machine learning detection is just not very robust, right? So in the machine learning model that we're using, all the detection for your position, for the eye openness, for your mouth openness, they will keep vibrating, right? The value is just not stable at all. So we add a lot of smoothness to try to make all these motions somehow make sense, right? So we're trying to make this value make sense. So we add a lot of smooth. So these are three general smooth that you can adjust, like the sensitivity ratio to detect the movement of your body, motion smoothness as well, and momentum smoothness. So these two are different smoothness, right? So for motion smoothness, we're trying to detect if you are moving. So for momentum smoothness, we're saying that if you are moving toward a direction, and certainly you're changing the direction, then we will apply a smooth to that as well. So you will not keep changing directions. It will be relatively stable. So these two are different smoothness, but they all play an effect to make our model lifelike, right? And the next one will be body. It's quite simple for your head rotation, neck rotation, chest rotation. A simple fact is that when we are slightly leaning our head, if you're using the face-only model, face-only machine learning model, we are simply detecting the tip of your head, the top position of your head, and your chin, and try to rotate your head. However, if you're just rotating your head without rotating your neck and your chest, it would look very odd. It would look like a robot or like something like that. So we have to share some of the rotation across your head, neck, and chest, right? So all of these values, 0 0.5, 4, and 1, will combine to 1, basically. So this is how the current ratio that we're using to share the rotation across your head, your neck, and also your chest. Right. And you can still adjust these values. To be honest, you can even change it to larger than 1. And it will still work, just that the motion might look a bit weird. But yeah, you can always adjust it as you like. And of course, for our head, we have another smoothness. We always need a lot of smoothness, so it makes more sense. For body as well, there are a lot of smoothness here, right? And after body, we have mouth, right? So mouth, we have it offset. It pretty much means that only when our mouth, the top lip and the bottom lip is opened, that is exceeding 0.01, will we consider your mouth actually being open, right? So the upper lip and your lower lip, for many people, even when you close your mouth, the value is not 0. The value is not 0. So we, if your model is constantly having your mouth open, even when you are closing your mouth, you will need to adjust this mouth offset value. For some people, their lips are just thicker, and for those thicker mouths, yes, please adjust this mouth offset value. You will be able to help you to close the mouth of your model. That's simple, right? So there's a ratio as well. You can adjust it. It basically means the magnitude of your mouth open and close, right? Of course, we have a smooth here. We always have a smooth here. And for brows, some model will be more vivid, but for the current model that I'm using, the brows just didn't change too much. You can try if your model actually will be able to move the mouth. How I'm doing this is that I'm using the sharpness facial expression. For many model, sharpness facial expression will make your brows higher. So that's how I'm currently. If your sharpness, if your brows detection is exceeding 0.5 compared to your eye, that's how I'm currently setting it, then we will add some sharpness to your facial model so your eyebrow can rise. So that's how currently it works. It might not work too well, but that's how currently it is working. So that's why it's not working for my model, because for my model, the sharpness facial expression just don't raise my eyebrows at all. Right, so for eye general, there are some crucial parameters or crucial settings that we can see here, right? The first one is eyes sync. As you can see right now, the two of my eyes open and close together. And by default, this eye sync variables is open, is toggle on, because like it's just more stable for the two eyes to move together. If we uncheck it, you will see that we can right now open and close one eye or not, right? So we'll be able to adjust some model. However, it becomes not so robust. As we stated before, the machine learning model is not very stable, And also, it depends a lot in the lighting environment that you are currently in, right? So if the lighting is not that well, if, for example, if the light is coming from one side of the like window, and the other side you don't have a light turned on, then the lighting is imbalanced, and the machine learning model detection is just not going to work too well, right? So I mostly always have this eye sync turned on, so it look better. However, if you are confident with the lighting that you're in the environment that you're in, you can just turn it off, and like so that you can like blink to the audience, and yeah, it's one setting that you can choose. And of course, there is a sync offset only when the two eyes are different exceeding these value. Will we start to make them different? Of course, if you always have the eye sync on, then we will not use these variable at all. This variable will not be useful if you turn it on. But if you turn it off, sometimes the eyes will still be synchronized. Only when the two eyes openness exceed this 0.05 difference will then behave differently. Of course, we have a smoothness value, and also for iris. Iris is like where you're looking, and we have an offset, which means wherever you are looking at, we're trying to change the model for it, right? So if you turn it to a higher value, then by default you will always look in the front, right? Only when the rotation exceeding a certain value will start to look at other directions. But currently it's set to 0, which means wherever you are looking at, it will always try to detect it. Right, so there is a ratio, which means the magnitude. If you change it to a very high value, you can rotate your iris like to the back of your head if you change it to a large value. Right, and now for our right eyes, there is a close offset and open offset. Interesting, right? So close offset basically means if your openness is smaller than 0.2, it will close. If your openness if your eye openness is larger than 0.25, it will open, which is interesting, right? Because you can see that these two values control the open and close of your eyes, but they are not the same value, which means when you close your eyes, to make it open again, you will need to open your eyes further. That's why it is not in the same value, right? So when you close it, it only need to be 0.2, but at the same value, it will not open. Only when you further open your eyes to 0.25 will your eyes actually open, right? So this is kind of like a state machine. When you close it, even when you are still at the 0.2 value, your eyes will not be closed. And only when they exceed a certain value will it be open. Will it be opened. And this is to prevent constant blinking, right? So as we stated, the machine learning model is not very stable, so the value might be vibrating between 0.19 and 0.21. It might be keep vibrating every single frame between 0.19 and 0.21 every single frame, right? So your eyes will keep closed and open if we just set it to 0.2, and it's just not looking well. So it's just very weird that your eyes keep constantly blinking, like something had happened, right? So that's why we're setting this 0.2 and 0.25 here. And interestingly, for some people, these are the value that you will most likely want to change, because for people on Earth, their eyes, the size of their eyes are just so different. right? I know someone that for the entire OpenLive3D, when we are trying to detect it, their model will just close their eyes forever, right? So I know someone who's like that. So adjust these values depends on your eyes. You can check how these will fit your like face more, personal face more. And of course, not only right eyes, we also have that for our left eye as well, right? So for left eyes, some people are not having synchronized. Okay, so every single person, their right eye and left eye will always be slightly different anyway. Just some people might have a larger difference, some people have a smaller difference, right? So adjust these value for your right eye and left eye to like make your model move smoother. For hand, right? So for hand gesture, interestingly, there is a tracking mode, right? So for tracking mode, we have three options here: face only, upper body, and heart, right? So these tracking modes are matching the like right sidebar for our face only and upper body detection or auto detection and heart shape, right? So these can be also see here in the hand. And of course, we have the smoothness for our hand. We have the grip ratio for our finger. Okay, so let's change it to upper body. And for the machine learning body to load, of course, we will need some time, right? So as we can see, these will be the grip ratio. Grip ratio is currently 1, and finger spread ratio will be how we spreading our finger like this, right? So these will be the ratio. 1 is the grip, 1 is the spreading. Okay. To make it smoother, let's change it to face only. Okay. And then position is quite obvious. Position tracking basically means if you move backward or forward, we'll try to detect you, and higher and lower, we also try to detect something, and these movements will be controlled by XYZ ratio, and that's the position. And for UI, there are some adjustments you can make to change the UI settings, like collapse the tracking mode and collapse the move selection. By default, I would just like uncheck these two because it makes sense to me. Right, so that's the settings for OpenLive3D. Hope is actually helpful, and that's it for today. Thank you. Bye bye.